Hello, in this video we're going to go through how to install the FT Grand Prix application and how to make a basic driver. So the first step is to clone the repository. This link will be in the description if you need to copy it. After we've cloned the repository, you want to navigate to it and set up a Python virtual environment. So we just use this command to set up the virtual environment in the venv folder. After we set up the virtual environment, we want to activate it so we don't mess up our existing Python install when we install dependencies. After activating it, you can just install the contents of the requirements.txt file. Once you've installed the requirements, you can use the following command to run the simulator. If everything worked fine, you should see the simulator show up on your screen. You can press space to unpause the simulator, and you can use N and P to cycle through the vehicles. It comes installed with a driver that works, but can be improved. But we don't really care about these drivers. We want to make our own. So to make your own driver, you want to open up the template. You want to open up the drivers/template file and copy it to your own driver. Let's call it mydriver.py. And then we're going to load this into the simulator. So we're going to make a new car, call it mydriver. Specify the mydriver file, and you can use any icon or color you want. After applying the driver, we can press space to unpause the simulation and start modifying the mydriver.py file. So if we change speed to 1 and then reload our code, we can make the driver go forwards. We can also make it go backwards, of course, and make it stationary. So what we want to do is use these LiDAR scans and incorporate them into our solution to make our car drive itself. So those LiDAR scans are passed in this ranges array. So ranges is an array starting with the scan here that goes counterclockwise around to this scan here. It's a bit unintuitive, but that's the way it's set up. Steering angle is also flipped, so you don't really need to think about it that much. So the simplest driver is the one that just follows the furthest LiDAR point. So to do this, first we only want to take the points in front of us. So there are 90 LiDAR points here, from 0, let's say it's 90. So we want to take the points from 30 to 60 to get the ones in this third here. So we can say in front is equal to range is 30 to 60. And this is a NumPy array, so you want to get the maximum angle here. So we'll say in front .arg max. This is going to return a number from 0 to 29, representing the largest value in this slice of 30 elements. Then we're going to convert that back to an angle. So we're going to say 30 plus maximum, and we're going to subtract 45 at the end so that steering one side is negative and steering the other side is positive. and then we're just going to always go at the same speed, but follow the steering angle. And let's see how our driver performs. Of course. So we've forgotten to convert from degrees to radians. So for math, import radians and convert this to radians before we use it. Our basic driver seems to be performing quite well. It's making turns at least. Of course, this can be improved a lot and made faster, but that's one of the most basic drivers you can make. Thank you for watching.